Hello, algebra students. Today we're going to be talking more about functions. In the last lesson, we just talked about functions in general. What makes a function, how each input can only have one output. In a graph, it has to pass the vertical line test. By the way, that's going to be important on one of your homework questions today. But today we're going to talk specifically about linear functions. And on the screen right now, you can see I've got 5 different ways of representing the exact same function. So first we've got just in words, an output is 3 more than the input. We could take those words and translate them into an equation, which is what we have right here. Remember, the output is always the y, so y equals, that's what is means. 3 more than the input is the input, x plus 3. I could take that equation, I could make it into an input-output table. And again, you've already practiced that a little bit. If I give you different numbers for the inputs for the x's, we could substitute it in to that equation, or we could just say, we're gonna have 3 more for each output. So when I have the -1, I'm gonna just add 3, and that gets me my output. Add 3 on each one of those, that gets me the outputs. Another way of looking at that same information, really, this input-output table is with a mapping diagram, which you've also looked at. And you can see each input is paired up with one output. It's a function. We can also take those same ordered pairs and graph them, and it makes that line right there. The fact that it's a straight line is important for this. So again, we've talked about functions, but today specifically talking about linear functions. Every one of these is going to be a straight line. The nice thing about this is that you have some experience with this from last year already. You've already done quite a bit of this work in terms of actually getting those linear functions. But today we're recognizing if they are linear or not. When I give you a graph, this should be a pretty easy answer for you to come up with if it's linear or nonlinear. Again, linear means it's a straight line. We don't even have a specific test or anything like this because we're just looking at the graphs. For A, that is clearly not a straight line. That's called a parabola. Comes when we've got something squared like y equals x squared, but this is not a straight line. That just means it's nonlinear. For B, this is a straight line. So it's linear. That's as much as you need to know on those kind of problems. If you've got graphs, decide is it a straight line or not a straight line? Linear or nonlinear? You also did this last year for deciding from a table. You could graph these if you wanted to. Personally, I would not do that. That's going to take extra time. You got to find graph paper and graph them and look at some of these numbers. They're really big. What we really need to decide is if we have a constant rate of change. And if we have a constant rate of change, remember we abbreviated that CROC last year, so constant rate of change. Not just because they're the best kind of shoes ever, it's that they have a constant rate of change. So when I'm looking at A, you can see that for the x's, here I'm going to add 3. And then I add 3 to go there, and again, add 3. So the x's, that's got a pattern. The y's, these are decreasing. That's okay. I'm just adding a -6. Add a -6, add a -6. Because I have the exact same numbers every single time, it is linear. It has a CROC, it has a constant rate of change. In B, I can look at this and we can say I'm going to add 2, add 2, add 2. Usually the x's are in a pattern, not always, but almost always they are. The y's, here I'm going to add 7, and then I'm going to add 11. Now, right away, I can see this is not a constant rate of change. I can continue. I can say, oh, that's adding 15. There is a pattern. Every time the amount that's being added is increased by 4, but if it's not the same thing every time, it's not a constant rate of change. So because this doesn't have a constant rate of change, doesn't have a croc, it's nonlinear. Again, if you wanted to graph this, you certainly could, but you would see that this would not be a straight line because those y's are not increasing consistently. All right, so for this one, what I want to do is I want to sort these different equations. Again, I realize that you don't know what some of these graphs look like. However, last year you worked with this, y equals mx plus b, right? We can find equations and hopefully you kind of recognize what this looks like, but I should be able to determine if these are going to be straight lines or not just by how the equation looks. If you have weird stuff like square roots or exponents, it's not going to be linear. If I have anything besides just a regular y and a regular m, and we can be adding or subtracting another number, we can be multiplying by stuff, that's fine. And I'm not even saying you have to get it into slope-intercept form. Could it be written in slope-intercept form? That's what's going to determine if it's linear or not. So if it can be written like y equals mx plus b, then it's linear. If it can't, if you've got extra stuff that doesn't fit that form, then it's nonlinear. So for instance, this first one, y equals the square root of x, that is definitely nonlinear. The second one, y equals 1/2 x plus 8. That is slope-intercept form. And again, if you remember back to last year, that means that you would start at the y-axis at 8, the slope is 1/2 or up 1/2, but that is definitely slope-intercept form. In the third equation, y equals 3 to the x, having that x as an exponent absolutely takes it off the table as linear. Same thing for the next one, x squared minus y equals 0, x squared, nonlinear. The next one, y equals 3.8. There's no x, I understand that. However, remember that this could look like y equals 0x plus 3.8. And I just lost my connection, so you can't really see it right now. But because I could have a 0 in front of the x, which would really make the x disappear, still waiting for my connection on this, but that is linear. There, got it again. So if I can make it look like that, not that you would have to write it like that, but it's okay to not have the x in there. It's still going to be linear. In the next one, with the x in the denominator, that's an issue. I can't use it like that because the x has to just be multiplied by whatever the m is. So that one is nonlinear. And for the last one, I know it doesn't look exactly like slope-intercept form, but again, I think that you should recognize that we could distribute that and get y equals 6x minus 6. That absolutely looks like slope-intercept form. So yes, that one is linear, and that would go over here. Okay, so today's homework is pretty fast and easy, I believe, because it's going to have those 3 basic sections. I'll give you graphs, and you decide if it's linear or nonlinear. It's a straight line or it's not a straight line. I'll give you tables. You decide if it's linear or not linear because it has a croc or it doesn't have a croc, constant rate of change. And then the third section is I'll give you equations. If they look like you could get them into slope-intercept form, then it's linear. If you can't get it into slope-intercept form, then it's nonlinear. There's one other question in there besides those 3 sections about looking at a graph and deciding if it's a function or not. Remember to use the vertical line test on that. When you're done, check your answers with the answer key. These pages are in Schoology, or you could just go into Clever if you'd like to. When you're all done with that, make sure that you use take the formative quiz in Schoology and let me know if you have any questions.